So hi guys, today we have another problem that is find the highest number, and basically you are given an array and you have to tell the maximum value of the array. You may think like, okay, it is so easy. Why they are giving this kind of questions? Basically that is not. If you look at the time complexity of this question that they are asking for, that is log n. So already you can see that this array is not sorted, right? So you cannot use binary search here. Then it will be a kind of tricky question. And this question is asked into the Amazon, right? And they are not stupid. We cannot ask this kind of questions. That will be so easy. So basically, what you have to do, you have to check for the uh, sorting order, basically. In that question, they already tell us that this sequence is either strictly increasing or can be strictly decreasing or can be strictly increasing and then decreasing. Basically, if you draw the graph of this, then you can see that suppose this is the graph and if you plot all the elements, then you can see that either it is strictly increasing or strictly decreasing or it will be like this. First of all, it will increase and then it will decrease. But in the question, there is not such a condition like you may not have this kind of array. So only we have to think about of this one, and this one. So if you got this kind of array, then it is so easy. How? Because if you have the starting point and the ending point, then you can obviously know that if you have the mid here, then the ending point is greater than the starting point, then definitely this element will be the greatest element. So this is pure for this kind of situations and also this kind of situation. So where the question be complicated, basically when the sequence is like this, then it will be kind of complicated, right? And also the sequence can be two type of this pattern. One is you may have this kind of sequence where the starting element will lie uh, below the ending element. What I am talking about. Basically, you may have a here for 4 and you may have 9 here, and the top element that can be suppose 10. Okay, so you may have this kind of sequence. So yeah, it can also occur, and opposite can be also occurred, right? So what can be the approach? Let us think about the binary search, how binary search works. In the normal situation, we usually find the target element into the sorted list, and we will use binary search to reduce our time complexity, right? So in that case, what we basically do, if the x that is given that is smaller than the current position, we will try to find in the this section, right? And otherwise, we will find this in this section. And suppose the x is smaller than the current meet, then we will reduce this portion, and we have to check for the new meet, and meet will be uh, less than or greater than x. If it is equal to the x, then we will return the meet value, the basic binary search that we do. So one thing we can notice that in which direction we have to check, that can be derived from the x and the meet, right? If x is smaller than meet, then we can check for the left side. If this condition satisfies, only we can check the left side. That is true. But here there is no such a condition. Let us have the graph again. Suppose this is the graph and the target node is this and the curve that is kind of this. If we make this as a left and this as a right, then what can be the meat? The meat can lie here, right? Now, in this graph, we can easily see that the top element that will lie here, but that will also not true for every case. It may happen like this. You may happen like this, where the L is here, right is, I mean, sorry, L is here and right is here, and the mid is here. Initially, we cannot determine in which side the maximum value will lie, right? So, what can we do? Basically, the technique is so simple. You have to just check for the right element and the left element also. And if the suppose here the left element is bigger than the current element and the right element is smaller than the current element, we can easily determine that the greater value that will always lie in this part. The greater value will never lie in this part. Why? Because this is a sequential manner. And when it is started to increase, then we have to decrease it also, right? For in this situation, especially. So basically, what we have to do, we have to check for the left side and the right side. If left side is bigger than the right side, we have to move for this part. And suppose there is another case that can occur. Basically, the left and right both are same value, and the curve is like this, and your maximum value lies in here. So this will also make the middle, the mid position, and it will be left, it will be right, and the element that is here, and we have to check for the left element and the right element. If both two elements are smaller than this guy, then we can tell that this mid is biggest. Obviously, in left side it is decreasing and the right side it is also decreasing. If both sides are decreasing and the elements that we have in the adjacent they are also smaller than this mid value, then obviously this is the maximum value. Okay, so this is the intuition behind our algorithm. We have to basically check for the left side and the right side, and we have to then determine in which side we will traverse for. So let us have a small dry run for this example. Like you have this kind of array. Suppose this is the right. The value is suppose okay, do not need the value. Basically, you have to make the idea clear. And this is the left. And suppose mid lies here. And obviously, in the left position, this is greater than the mid and the right. So we will discard this part, and our new right will be this one, and we may have meat here. Also, we have to check for the left and right side, and then determine the which side we have to reduce and which side it is valid or not. So here we can clearly see that this part is greater and this part is lesser than this position. So we can reduce this one also, and our new right will be this one. Then middle may have the position this one. We have to check for the left and right side also, and right is bigger than the left, so we can reduce this part, and our left will be here. So this process will continue until and unless the left will be equal to right. If this condition happen, so then we have to break our while loop, and we will get the answer. So basically there is two way to get the answer when the left value and the right value both are smaller than the mid, then we have to return the mid. That is our answer. And another answer that will be when our while loop will break, then the left and right, those positions will point to the perfect that the main answer, and we have to return the value of the left or right. You can use one of them. So this is the idea. Let us try to code it up. So we have to make binary search here, and Let us first declare left and right. That is int L will be 0, R will be, that is A dot size minus 1, and while L less than R, we will continue the procedure, and we have to get the meet position, that is it will be L plus R by 2, sorry, and we have to get the left value and the right value also, that is int left error meet minus 1 and RT, that is error meet plus 1. If error of meet, sorry, not error, uh, it is A. So A of meet, if it is greater than LF, and also A dot meet if it is greater than R, sorry, RT, then we can return A of meet. Otherwise, we have to check for the which part we have to consider. If A of meet, sorry, if LF that is bigger than the RF, RT, then it is sure that the answer will lie on the left hand side. So we can reduce RT, that is uh, R is equal to I meet minus 1, and for another case that will lie in the else part, that is L is equal to meet plus 1. So after all, we have to return ARR of, sorry, A of L, or you can use A of R. So let us try to run the code. Okay, so this example, this is working fine. Let us take, okay, so this is the example, and we have to take another example for cross checking. Okay, we can take this example also. Let us have a run. Okay, so this is matching also. Let us try to submit our code. So this is working fine. So this is how we can solve this question, and the time complexity that will be obviously log n, and the space complexity that is 1, because we are not taking any extra space. And so this is the solution for this problem, and hopefully the thing is clear to you. So bye, see you in the next video.